Well, welcome back to the third and last video in this series on the EICO 221 vacuum tube voltmeter. I've gone through and made the repairs that needed to be made, and in this video I will go through and show what I did and how I updated it, and then we'll go through the calibration procedure and see how well this meter performs. Take it for a test drive. Before getting into the specifics of what I did, just a few details about things that were replaced on the circuit. First of all, with the exception of R13 through 17 and then 18 through 22, which are wire wound precision 1% tolerance resistors. All the rest of the resistors in this were carbon composition, and all except for one had drifted out of specification. And I don't remember which one it was right now, but I went ahead and replaced all of them, including the one that had not drifted, just for good measure. That included, as we saw in the last video, the 15 mega ohm resistor in the lead assembly. That had to be replaced as well. A couple other things. The two of the three tubes tested out fine. The power rectifier and the bridge amplifier both tested fine on my emissions tester. The diode here, the diode rectifier, this is the 6H6 tube that was in the metallic case. This one actually tested out to have a short in it. So I had to swap that one out for the good 6H6 tube that was in the first EICO that was discussed in the previous two videos, and that tested out to be fine. One other thing that I did was I just omitted this bypass capacitor here on this side of the power line. It was leaky. I had a 0.02 microfarad safety capacitor that I could have installed here, but the more I looked at it, I thought, well, this really isn't serving a purpose in this circuit as far as filtering out kind of power line noise, and I don't think that that's going to be a big issue when I use this. What I did do, however, was I installed a polarized power cord on this and then made sure that the hot side was always going to the switch, and before the switch in the circuit I added a fuse, which I'll point out on the chassis in a moment. And I put a 1/2 amp fuse in there as well. So the rationale behind that is that if something were to ever happen to the primary and the side of this transformer here and it shorted out, that fuse would pop and provide some protection. Okay, I don't think there's really anything else to go over on the schematic. So let's jump in and see what I did on the chassis assembly. First of all, I installed a new polarized supple power cord. And because there's a power transformer on this, this chassis is in fact isolated. There was you will remember that originally there was a D cell that was soldered into the circuit by 2 wires. And that D cell just, let me get a light here so we can see a little bit better. That D cell just clipped in to a battery clip back there. I didn't see any reason per se to have a D cell in there, and I didn't have a D cell size battery holder. I had a C cell size battery holder. So I decided to put that in so that I didn't have to solder a battery. And I put long enough leads on this so that you could work on the chassis and have it out of the case easily. And it turns out that battery holder just fits into the clip that was designed for the D cell quite nicely. Now let's bring this over here and take a better look at it. So you can see all of these capacitors have been updated and changed. The fuse, the power line comes in here, and the hot side goes directly to a fuse which I've installed right down here in this kind of shelf of the case. And you can see, it just attaches with a single screw right there. So that worked out very nicely. A couple other things to point out. All of the wire wound resistors tested fine, although you can still see a little bit of char on this one, and that was the 95K. I didn't have a replacement for the 9.5 ohm resistor here. But what I did have was a stock of the 4.7 ohm resistors. And I was able to go through and find two 4.7 ohms that were a little bit on the high side, so that when you add them in series, you get very, very close to 9.5 ohms. I think this one turned out to be 9.47 or something like that. So definitely close enough anyway. All right, I think that basically covers it. Oh, one other thing, the zero adjust potentiometer. I was able to clean it out and lubricate it a little bit and clean it and work it, and it's not quite as loose as the ohms adjust resistor potentiometer here, but it's actually pretty good. It's vastly improved. There's just a little bit of tension or resistance in it, but otherwise I think it's fine. And I checked it with an ohm meter, and it the resistance is right on, so that's fine. I also went through with a little bit of deoxit and cleaned the contacts on each of these switches, so those are now clean and should make good contact. All right, let's set this up here and bring it over. The way that this is calibrated is with a series of adjustments to these 4 potentiometers here. And so this has to be out of the case in order to calibrate it. So let me set this up here. All right, I've centered this so that we can see what's going on, and we're going to proceed to calibrate this EICO 221 vacuum tube voltmeter. And I've got this not in the case. I need to be able to access 4 potentiometers on the inside of the chassis. But we're going to use, instead of 2 flashlight batteries, which is called for in the directions in the calibration procedure, we're going to use this DMM checker as a 5-volt DC source. And then there's some standard precision resistors in that as well, so that we can use that to check the ohm meter on the vacuum tube voltmeter. There's no calibration per se for the ohm scale. And then when we go to calibrate the AC, we're going to use one of these BK Precision Model 1653 isolated power supplies, AC power supplies. So we'll set that to 100 volts or whatever we want according to a DMM, and then we'll use that as a source, calibrated, a known source for the EICO. All right, so I've got the calibration procedure right here, and we'll just walk through that. So the first step is to, of course, turn this on. I've had this on for maybe 10 minutes to warm up. Generally, you should have it on for longer, but 10 minutes isn't probably too bad for this case. All right, so the first thing it says is to set this to negative DC volts and to short out the common probe and the sensing probe, and to set the zero adjust to 0. And so there we go. Just to show that this pod is working and functional. When I adjust it, I get deflection over a very substantial part of the meter. So let's zero this. This is really precarious the way that it's up here. And there'll be a little bit of parallax because this is off at an angle to avoid glare. But that's pretty close to 0. All right. And now I'm going to put the ground to the positive voltage source and the positive lead through the 15 megohm resistor to that. And there is no earthly reason why that should read 5 volts right on. That is just a fluke of nature that it was so well done. But there I've just adjusted that a bit. And so now what we're going to do is we're going to take this off. We're going to change this over to DC plus. We're going to do the same thing again by setting the zero adjust, and that's actually pretty good the way that it is. Okay. Now we're going to put the positive lead going through the probe and the ground lead on the negative, and you can see that one doesn't agree. So we're going to go back here to the DC plus calibration potentiometer, and we're going to just tweak that over here to 5 volts. Okay. So the DC calibration is now done. And let me pause this for just a minute and set up the AC voltage source with the DMM. And so let me do that and I'll be right back. Okay, I've set the BK Precision source up to 100.0 volts AC, which I'm reading on my Fluke Model 8010A digital multimeter. And for the AC voltmeter calibration stage, it says to set the function switch at AC to 1000 volts, which is all the way over there. To short the AC ohms test lead, that's now a black test lead, to the ground, and adjust the zero, adjust control until it reads 0. And you see that, in fact, we don't actually have to do any adjustment. It's already set there. Okay. Turn the range switch to 5 volts. Okay. And adjust the AC shift balance potentiometer until the meter returns to 0. So that's still with these shorted out. And that's not quite at 0, although it's actually pretty good. So I've identified the right meter, right potentiometer. And yes, I am able to peak that up. Okay, so now that's at 0. And then the next step now is to connect the leads up to the AC supply on the 500 volt position. Okay, so there's 100 volts and there's 500 volts. And then to make the final calibration on the AC cal pot, which turns out to be R30 on the top of the back rack. So let me hook up the AC and do that. Okay, and so there's the AC. And on the 500 volt scale, so it means multiply everything on the top scale by 100. So instead of 5.0 being the maximum, it'll be 500. And if I kick the tripod here, okay, it's actually not too badly out of adjustment. So 1 on the scale is actually 100 volts. And there's that. This is how we pronounce the meter now calibrated. But let's just see how well it does on the other scales. So let me take the power off and bring it over to 100. And since I've got 100 volts, this should now deflect full scale. And it's not too bad. It actually reads, what, 9246, 96 volts there. Okay, so let's disconnect that, put it over on the 1000 volt scale, and so that then should just barely come up to somewhere right around 1, and in fact it's bang on at 1. This is supposed to be plus or minus 5% accuracy on the AC scale. And so it's very good on the 1000 volt scale and very good on the 500 volt scale. On the 100 volt scale, it read, what, 96? And so 5% of 100 would mean that any reading between 95 volts and 105 volts would be within the range of accuracy quoted on the meter. And in fact, we got that. We got 96 volts. So, you know, we could peak it up to make it more accurate on any given scale, but there's no reason to do that because this is not a high accuracy instrument. This is going to be an instrument that we use to kind of give us a sense of maximum peaks as we go through a range of voltages, and in particular we'll be measuring DC voltages, not AC voltages, when we align radios and things like that. So let me take the AC off now, and let's just see how accurate it is on the resistance settings. All right, I've removed the AC power from this, and let me just move the DC probe out of the way. And so here now is the resistance and AC probe right here. And here is the ground lead. Notice that I replaced the somewhat oxidized ground lead with a new rubber-coated alligator clip. So the way that one goes about doing that is I'm going to set it here on the ×1 scale. I'm going to just set this to 0, okay? And should actually set it on resistance. So I'm going to 0 this out. Okay, and there's 0. And then adjust this so that it reads infinity on an open circuit, and it does. All right. And so let me now just put this on the 100 ohm resistor. And look at that. We have 100 ohms. So that's promising. All right, now let me bring this up to the ×10 scale, and again, 0 this out here. Okay, and then set it to infinity, and there we go. And so now I'm going to, on the ×10 scale, test the 100 ohm resistor, and you see it's extremely close to 10 on the meter, as it should be. Let me also look at the 1K resistor on this. So this should read 100. And in fact, that is in fact what we get. This is promising. Okay, let's bring this up to the ×1000 scale. Again, 0 it out. Okay, roughly. And that's infinity, that's good. And let's read 1K here. So this should read exactly 1 times 1000 is 1K, and that's what the precision resistor is. And let's look at this. The 10K resistor now should read 10, and it does. And now let's read 100K. So this should go up to 100, and there we go. All right. And we could go through and check, you know, these kind of decades on the successive remaining resistance scales, but I don't really feel the need to do that in this video. So there we are. This is cleaned up quite nicely. I think we can declare victory. It certainly works on the resistance scales. And we calibrated on the 100 volts AC scale and to a 5 volt DC standard. And it seemed to work. So let's just go back and test that 5 volt now that we've kind of been mucking about a little bit. So this is on the DC plus scale, and we're going to bring it down here to the ×10 scale, and I'm going to clip that to the ground, and with the DC probe I'm going to touch that, and what do we get here? So this is on the 10 volt scale, and you see we get 5 volts. That's exactly what we should get. Let's just bring it down to this scale here, the ×1 scale. And so this should be 5 volts, and that's what it is. All right. So I think this is a done deal. I think we can button this back up and put it in its case, and we have a functional EICO 221 vacuum tube voltmeter restored and working. I hope you've found this interesting. And again, just want to reiterate that there's dangerous voltages inside this, and you should not attempt to do this at home if you are not trained in working with high voltages. If you do so at your own risk. But again, I hope you've found this interesting and illustrative. If you do, please give it a big thumbs up below. Thanks a lot for watching.